So this question has been asked in GATE 2017. We are told to find the average waiting time using preemptive priority scheduling. Now, in preemptive priority scheduling, a process with higher priority will always get scheduled first. Now, let's see how it works. See, now we find that there are 5 processes available with us, and process P2 has the highest priority and process P5 has the lowest priority. Now, process P2, although it has the highest priority, it is not the first process to be available. Look at its arrival time. Its arrival time is the 5th time unit. The first process to be available is process P1, which is available at time unit 0. So this is the first process to be available to me, but it has a priority of 2. Okay, so we'll schedule process P1 first because we have no other process available at time unit 0. So P1 is not competing against any process. So it is the only one available at time unit 0. So it gets scheduled. So process P1 gets scheduled. For how many units of time? Now look, the next process to arrive is process P4 at time unit 2. And it has a higher priority. See, its priority is 1, while that of process P1 is 2. So P1 will execute only till the point when P4 is available. So P4 is available at time unit 2. So P1 executes for 2 units, right? So P1 executes for 2 units and gives up the CPU to P4. So P1 now has 9 units of burst time left. Now P4 gets hold of the CPU. Now P4 is not the process with the highest priority, mind you. It has a priority of 1. For how long will P4 execute? P4 will execute till the time a higher priority process is available in the system or P4 has finished off its burst time completely. Now we can find that the next process to be available is P2 at time unit 5, and it also happens to be the process with the highest priority. So process P4 will run till the 5th unit of time. So it will run for 3 units till 5th unit of time, and it will have 7 more units left, and it will give up the CPU to P2, which is available at the 5th unit of time and has the highest priority. So process P2 will run to completion because it has the highest priority. No matter which process arrives after P2, it will not be able to overtake it because its priority is the highest. So P2 will run for burst time units. That means for 28 units. So 5 plus 28 will give me 33. So that will bring an end to the execution of P2. Now by 33 units of time, all my processes are available. Now the scheduling will take place strictly according to the priority of the processes. Now out of all the processes available at the current unit of time, that is 33rd unit of time, we find that process P4 has the highest priority, right? It has a priority of 1. So process P4 will now get hold of the CPU and it will run to completion. That means it will run for 7 units directly. So it will run for 7 units, giving a time of 40. So P4 has finished its execution. Now out of P1, P3 and P5, we find P1 to have the highest priority. So P1 gets scheduled next. And for how many units of time? P1 will get executed for its remaining burst time, that is 9 units. So P1 finishes off its execution till the 49th unit of time. Now after P1 executes, we have P3 and P5 available with us, out of which P3 has the higher priority, so it will get scheduled next and will run for its execution time completely. That means it will run for 2 units completely, and we will have the 51st unit of time available with us. Now after P3 executes, the only process left in the system is the process with the lowest priority, that is P5, and so P5 gets scheduled next and it will run for 16 units of time, giving a completion time of 67 units. So that brings an end to the scheduling of all the processes. Now our job is to find the average waiting time. Now in order to find the average waiting time, we need the completion time of the processes as well as their turnaround time. So first we need to find the completion time. So let's find the completion time first. So the completion time will be found by looking at the NAT chart. Now if you find the NAT chart, you will find that processes have repeated. This generally happens in preemptive scheduling algorithms. In preemptive scheduling algorithms, what we do is we scan the NAT chart from right to left, and the first time we see a process, we note its completion time. So let's see. So I'm scanning from right to left. I find P5. Now I find this time frame of P5 to range from 51 to 67. So this will be its completion time. So the completion time of P5 is 67. Next, I encounter P3. I haven't seen P3 before, so I'll consider this time frame. This time frame is getting over at the 51st unit of time. So P3 will have a completion time of 51. Moving on, I encounter P1 for the first time. Its time frame is getting over at 49th unit of time. So its completion time is 49. Next, we encounter P4 for the first time. Its time slot is getting over at 40th unit of time. So P4 has a completion time of 40. And we encounter P2 for the first time. See, we haven't seen P2 before. We encounter P2 for the first time, and its time slot is getting over at 33 unit of time. So its completion time is 33. And now see, we encounter P4, but we have already seen P4 once, so we'll ignore this. We encounter P1 a second time, so we'll ignore it. Now, to find the turnaround time. Now, if we have to find the turnaround time, what we do is we subtract the arrival time from the completion time, because turnaround time denotes the total time spent by a process in the system. So if I subtract arrival time from completion time for process P1, I get 49. For process P2, I get 28. For process P3, I get 51 minus 12 will give me 49, 39. And for process P4, I get 38. For process P5, I get 58, right? So this gives me the turnaround time. Now I need the turnaround time in order to be able to compute the waiting time, because waiting time is the time spent by a process waiting for the CPU. Now, what is the time spent by a process executing on the CPU? The time that is spent by a process executing on the CPU is given by the burst time. So if I subtract the burst time from the total time spent by a process in the system, what I'm left with is essentially the waiting time of the processes, because turnaround time is the total time spent by a process in the system. So from the total time, I'm subtracting the CPU time, and I'm left with the waiting time. So turnaround time minus the burst time will give me the waiting time. So 49 minus the total burst time, mind you, not the, the intermediate burst times, the total burst time, that is 11. So 49 minus 11 will give me 38. 28 minus 28 will give me 0. That means process P2 did not wait for any time. Of course, it makes sense, right? Because it is the highest priority process. So the highest priority process will never wait for the CPU. Next, we have process P3. Process P3 has a turnaround time of 39 and a burst time of 2, giving a waiting time of 37. Process P4 has a turnaround time of 38 and a burst time of 10, giving a waiting time of 28. Process P5 has a turnaround time of 58 and a burst time of 16, giving a waiting time of 42. So now, if I have to find the average waiting time, what I have to do is I have to sum up the individual waiting time of each process and divide it by the number of processes. So how many processes do I have? I have 5 processes. Now let's do the calculation. So we have 38 plus 37 giving us 75. 75 plus 28 is giving us 85, 95, 99, 103. And here we have 105, 145, right? So we have 145 as the sum of the waiting time. Divided by 5 will give us 5 2s are 10 and 9, so that's 29, right? So the average waiting time is 29 time units. So I hope this helps. Thank you.